Okay, so you may remember in a past video I posted a jet mini lathe upgrade to infinite variable speed. And that was accomplished with the use of a DC motor from a treadmill, a silicon controlled rectifier, and I believe this is a 10 kilo ohm, what is it, a 10 kilo ohm variable resistor. And it just plugs in directly to the SCR, and with the help of an inductor allows the motor to do what it does. And what's really great about this setup is because when these motors receive load and it's sensing that something's trying to slow it down, the SCR senses that and picks up a little bit of the torque for you. So as you put in a big roughing gouge into some wood, the SCR helps you kind of maintain that torque load and keep your RPMs up. It's really fantastic, and I don't know why I don't see more people doing this. It is an amazing thing. I didn't like how I couldn't detension the belt. Of course, the belt is attached to the pulleys, and we're going to look at all of this, but the pulleys are inside here, and the belt runs down through here and attaches to the nose, the serpentine pulley on the front of this big weighted whatever flywheel that the motor has, which is another benefit too. It helps maintain torque or RPMs anyway. I didn't like how I couldn't detension it, so I come up with these, and bear with these clamps, they're in the way, but I just kind of just roughed this out to where it wouldn't move. And I've just placed blocks in various locations just so I could make sure that it wouldn't move. And all I did was drilled this out to a 5/16, and this is just a metal bit, but I drilled this out 5/16, and I stopped down here where I could put in a flat washer, a washer too small for the bolt, obviously. Tapped it, 3/8 16, right there. And I just chucked this into my impact driver and just one pass tapped it, and it made these tights. It made this tight. So as I screw this down, this is just strapped down really well, and this will raise up, and it'll put tension on the belt. It's a very accurate way to do it. I can just simply tighten these up independently. There's one in the back too, but we'll get more into that. But this is a really good upgrade, and this is just functional. I tried to come up with a way to strap this down, or not strap it, but maybe use like metal straps that's used for guttering and go through all that. But the only thing that I think I'll probably need to do maybe over time is maybe put some stop blocks just to keep the motor from walking. I know it's so tight, I just don't think that that's going to be an issue. And if it is, I'll adjust for that and put in side stops for the motor as well. But I don't think it's going to be an issue. Let's take a look at how this raises and lowers. Okay, and as you've probably already noticed, it's not a good idea to use just your standard sockets in an impact situation. This little Craftsman right angle impact driver doesn't really have enough torque, I don't think, to do any damage. But it's not something you would want to do to a specified impact wrench like you would buy. Those big 24-volt impact wrenches that I've seen are really nice. I don't have one, and I don't have any impact sockets. But in doing this, it's just a matter of just chucking it in. And I'm using an adapter. This is just a 1/4 inch impact to 3/8 inch drive on a socket. This happens to be a 17 millimeter. The thread's 3/8 16, but it's these bolts are from China because that's what my lathe was actually bolted down with when it was on the crate. And I just pardon the noise, but you just raise it up. And as I do that, I reach in here and check the tension on the belt. And that's pretty close, but there's a little bit more deflection than I like, and it wouldn't take just a little bit more to do it. Yeah, that's perfect right there. Here's a shot of the head pulleys on this lathe. And the main thing, if you ever try to do this setup, just make sure that your belt, this happens to be a urethane belt, just make sure it is running true and not kicked to one side or the other. That would cause wear. As these serpentine, I believe they're called, pulleys have little ridges in them, your belt does too, and you can wear those out. So just make sure it runs straight and it's in its grooves where it should be. You won't have any trouble. Okay, so I'm going to try to give you an example of just lowering this and removing the belt from the pulley. I've had to do this in a couple takes. There's a lot of vibration when I use the impact driver, and I can't really figure out why. I think these iPhones are really susceptible to interference, or just I don't know. Is it electromagnetic or what? I'm getting a vibration from somewhere, and I don't understand. The feet are on the concrete below it, so maybe it's just sensitive. But anyway, here we go. So the object is, you want to make sure that everything is in the correct height to do what you need to do. If you can just lower by whatever this is, you know, 1/8 of an inch on each side, or a quarter in my case, then you need to be able to still be able to get the belt off. If you lower it down and you still have too much tension to get the belt off, you haven't really accomplished much. But I'm going to lower it and then see. I'm going to show you an example of how easy it is to get the belt off. Let me go over here on this side so I'm out of the way. Okay, that jack is all the way out, and that is all the way out. And as you can see, there's tension that has been removed from the belt, and all I have to do is just kind of just rotate the headstock and just spin it right off. So now it's loose. It's kind of dark in there, but you can see it. And to put it back on is the same process. You just want to make sure that you stay on the correct pulley on the headstock. Mine has 6 pulleys because this lathe was not variable speed. The jet variable speed lathes had 3 pulleys on top. It wasn't infinite variable, so I've upgraded from their version of variable speed, which isn't very variable. Okay, so tensioning it back up now, same as before, and you just want to keep it easy, even on both sides. And I realized that if you had a huge lathe, this is not an option. I'm just speaking for these small lathes. A couple things you could get into with, if you didn't do this correctly, or you didn't do it as accurate as possible, you could torque your ways over the length of your bed, and that would be a bad thing. But in this situation, the lathe is so short, and it's a wood lathe. I'm not looking for thousandths tolerances. This is going to be great. Okay, so now that all of that is said, let's fire this up and let you see it in action. So in order for this to work, this has to be off on the variable resistor before you begin. Turn the lathe on, and then the SCR, you can't see it, it has a red light to let you know that you have power to the SCR. Right there. And at that point you're ready to go. And this works so well for just slow turning. If you want to just barely get it going, sometimes you have to kind of get it going and back it off, but it works really well for applying CA glue to say a pen blank or something. And that would be a little fast for that application. Let's see if we can turn it down. Yeah, there you go. That's slow enough to where you can see the threads in the chuck winding. So let's speed it up. It's about 1,000 RPMs right there. That's 2,000, give or take, maybe 2,100. Super smooth, and I didn't notice any torquing of the actual motor itself. Perhaps when I put some load on it, but we'll see how it goes. And I kind of expect these to be temporary. But maybe not. Maybe they'll be good to go. But only time will tell. Okay, something that I wanted to show you that was important and I left out. This motor is rated at 6,700 RPMs. I mean, that's how fast it'll eat at full current. So It is a let me look here, 2.5 horsepower, and will go almost twice as fast as what my lathe is rated at. My lathe is rated at 3975, so just under 4,000 RPM, and the motor will do 6,700. Let me show you how I remedied that. Okay, you may remember seeing this little bitty piece of reflective tape on the side of my headstock. That serves a purpose. It's so I can use my optical RPM gauge, and it'll measure it and tell me how fast it's turning. And I actually use a pin lid for the stop on the variable resistor. So if I were to turn this all the way as far as the resistor would go, it would go way too fast for the rated capabilities of my lathe. So this is just glued on there, epoxy, super glue, something. And same for the cap. And I just pulled the little clip off to make contact with the cap using my optical, what are they called? RPM gauge. That doesn't sound right. I'm having a brain moment. But using that, then I'm able to determine that my lathe is not running past 4,000 RPMs. Okay, well, thanks for tuning in. I appreciate you clicking that video. It's just kind of a fun little project. It didn't have a whole lot of substance, but I think there's some good information there. And I got a Grizzly 30th anniversary LANV G0555. I have 2 years of use with that tool, and I'm going to give you likes and dislikes on it next.